podcasts so matter. Okay, we are going to do in economics today. And so same idea as always, we're just doing optimization. We're looking to maximize or minimize something. Usually we're looking to minimize profit. Sorry, did I say minimize profit? I would make a terrible capitalist, wouldn't I? We're looking to maximize profit. We're looking to maximize revenue. We're often looking to minimize cost. Okay, so let's assume that Mr. Rogers is holding a live webcast for free. 300 people will watch. Of course, this is paltry compared to my well-known video, Converting Vertex to Standard Form, which I will point out has 300,000 views on it. And almost that many swears at the bottom. Okay, for each dollar increase in price, 20 fewer people will watch. And of course, that's their loss. Anyway, this is revenue. It depends on the number of people that show up as well as the price that they pay. Okay, so pretty simple. If 100 people show up and they pay $2 each, I'm going to make $200, et cetera, et cetera. Mind you, that's not what our revenue model here is, but that's how revenue works. We can find revenue as a function of price, or we can find revenue as a function of the number of people that show up. So just like always, in any optimization problem, the trick is trying to get everything expressed in terms of one variable. In this case, this is actually two variables, and so I'd have to, I can't do calculus on two variables, at least not in grade 12. Okay. What we need to do then is we need to express things in terms of one variable, and the key here is just the fact that the number of people that show up is related to the price that I charge. And so in this case, the number of people that show up is 300, and then that's going to be 20 fewer people times whatever the price is that I charge. Okay, so we're working down the revenue as a function of price side, so I'm going to substitute this expression for n into my revenue relationship here, and this is 300 minus 20p, 20 times price times price, and so this ends up being 300p minus 20p squared, which is one of those nice, did I say nice? I mean sad, frowny face parabolas. All right, since we're doing calculus here and we're trying to optimize things, obviously I want to maximize my revenue here. So what should I do? I know what you're all thinking. You're thinking you should take the derivative. And the answer is you should take the derivative. Okay. And I know that Maddie was just noticing that I didn't have a squared on my p. Yeah, okay. So there we go. The derivative is 300 minus 40 times the price. Okay. We found the derivative, and of course for a critical point, r prime has got to be equal to 0. And so 0 is equal to 300 minus 40p. And so if I do all of that simplification, I wind up with a price equal to $7.50. Okay, so that is going to be the price that gives me that nice turning point, and I know at a turning point I've got a maximum. It's an upside down parabola, and so I will have maximized revenue. I can just substitute this price back into my revenue function here. So the revenue at $7.50, and I can substitute it in and do all the algebra, but I'm pretty sure everybody can do it. It winds up being $1,250. So we've worked down the revenue as a function of price side. This, while it was easier to do, is actually a little bit less common because when we're doing economics, we also want to know cost so that we can calculate profit. Cost is usually expressed in terms of the number of units that we produce, okay? Rather than the price we charge, we usually know what our costs are in terms of units of production. So what we need to do is work down this side. We need to be able to express revenue as a function of the number of tickets sold so that we can integrate it with a cost function a little bit later. So all we really have to do is rearrange this, this relationship, okay? So the number is equal to 300 minus 20p. We want to have this as p equals something in terms of n. So this is n minus 300 over negative 20 is equal to the price. And I can switch this around a little bit so I don't have a negative on the bottom. Not that that's a big deal. Okay, so now I've got price expressed as a function of the numbers here. I can substitute this back into my revenue, and then I'm going to have an expression that's going to be in terms of the number of units that I sold. Okay, I'm just going to fix this up. This is, what is 3,000 divided by 20? It's 15. And this is minus n over 20. Okay, so that's maybe just a little bit tidier. Now I'm all ready to do my substitution, and I will get R in terms of n, revenue in terms of the number. And so R in terms of n is equal to n times 15 minus n over 20, which is equal to 15n minus n squared over 20. And so there's revenue as a function of the number of tickets that I sell. For critical points, I need to take the derivative and set it equal to 0. So r primed at n is equal to 15 minus 2n over 20. And of course, I can simplify that a little bit, 15 minus n over 10. I'm going to set that equal to 0 so that I can find my maximums. And I'm going to shift this over here. Negative 15 is equal to negative n over 10. And so that just means that to maximize revenue, what I need to do is sell 150 tickets. So we're still playing the same game. Instead of figuring out the price to get the best revenue, we are approaching it from a numbers standpoint here. And so at 150 attendees, I'm going to maximize revenue. And I can just plug 150 back into the original revenue function, do the algebra. And then in this case, we're going to find out how many tickets we need to sell. Okay, so R at 150 is going to be $1,250 again. Okay, so same maximum revenue as before. Okay, that's it. Excuse me for just a minute. I need to. Okay, I'm going to poll my audience. Did that all make sense? Maddie, did I make any mistakes? Oh, I'm getting a thumbs up. I didn't make any mistakes. That is so good. Okay, we're just going to talk about integrating cost into this model now, and which is really, really simple. And then I'll talk about what they call marginal revenue or marginal returns and marginal cost. And just the fact that those things are.
Where did the 1250 come from, Mr. Rogers?
I just plugged 150 into my original relationship. So the question was, where did the 1250 come in? I just plugged it in, and I did the calculation ahead of time so that I wouldn't make any mistakes.
But is that just like 150? Like what numbers was that you plugged in to get that?
So this was 150 tickets was what I had to sell. So I plugged it back into my R at n function. Okay, so I just plugged it back into the original function. All right. So now we're going to look at profit. And profit, when we sell n units is just equal to the revenue when we sell that many units, subtract the cost when we sell that many units. Okay, not a big surprise there. So an example cost structure might be, so it costs $100 in advertising to hold the event. And then YouTube charges, greedy YouTube charges 50 cents. If I put $1 here, if I put it, I don't know if that's right. No, this is being expressed in dollars. So there we go. I have to put a dollar sign here, or the international currency police will come and get me. Okay, it costs $100 to hold the event. YouTube charges 50 cents per viewer. What is my profit function in terms of N now? So you'll notice that the number of users is right in my cost function here. So the price as a function of N is just equal to my original function, which is equal to 15N minus N squared over 20. And then I have to subtract cost. So I'm going to subtract $100 to hold the event, as well as 0.5 times the number of users. Okay. And so this winds up being 14.5 N minus N squared over, oh my goodness, this is a dog's breakfast. There we go. So there's my profit function, okay? YouTube's taking a little cut. This profit function has changed a little bit. So my maximum is going to have changed a little bit. I don't think we need to do this. To maximize profit though, I'm just going to take the derivative of this function. Now that we've got the costs, I'm going to set it equal to 0. I'm going to find out, you know, how many tickets will maximize that revenue, and then plug it back in to figure out what my revenue is. Okay? Okay so far? That wasn't too much of a leap, was it? To the cost, to the profit function from the revenue function? Okay. Last thing I'm going to talk about is a thing called marginal returns. So marginal returns, marginal profit, marginal cost. And when you take an economics course, they talk about those things a lot. So we can talk about marginal returns or marginal revenue, sometimes what it's called, marginal costs, and then there is marginal profit. Okay, so when I put a crop of canola in, for example, I'm adding nitrogen. As I add nitrogen, the yield goes up, but the yield just doesn't continuously rise. It rises up to a maximum. And so I wind up with what they call diminishing marginal returns. As I increase my inputs, every pound of nitrogen actually results in less and less additional canola. And so we actually are interested in matching our marginal revenue and our marginal costs. All marginal, any of these things are, so marginal revenue is the revenue from producing one additional unit. Okay, marginal costs are the costs of producing one additional unit. And marginal profit is the additional profit that I would get from producing or selling one additional unit. Okay, so marginal cost is equal to the cost of producing the next unit minus the cost of producing the previous unit. So for example, the cost of selling 101 tickets minus the cost of selling 100 tickets. And because we just have an increase of 1, we only have to divide that by 1. So you might recognize this as being the difference quotient. Our old friend, the difference quotient. Okay. This is kind of relevant if you're producing heavy equipment or modular nuclear reactors or something like that, where I can only produce, say, one more tunneling unit. So I can't produce an extra half a tunneling unit. For a lot of things, though, we really don't have to count it in terms of one additional unit. So for canola, like, I'm happy if I get 1.1 tons instead of 1.095 tons, okay? But since this is the difference quotient, really, this is approximately equal to, so the marginal cost is approximately equal to the derivative of the cost at n units. So if I wanted to know how much it costs to produce 100 units, how much extra it would cost to produce 101 units, really I can take the derivative for producing 100 units, and that's going to tell me my marginal cost. Okay. That's it. How'd I do? 12 minutes. So we have a test coming up 2 days from now. We also cross the equinox of the course sometime later this week, meaning that, and coincidentally, it seems like we're coming up on the actual equinox, the seasonal equinox, in a couple of weeks as well. So your test is going to be graph sketching and optimization. So first question is probably going to be sketching a nice cubic function, something that's easy to take the first and second derivative. You're going to figure out positive and negative intervals where it's increasing and decreasing, concavity. So you're going to be taking derivatives using interval tables, x and y intercepts. Did I say that? I didn't say that, did I? So that's going to be your first question. Now it's got to be easy because this is a big test. Second and third questions, I probably give you the first derivative or give you the second derivative of the rational function, and I asked you for like intervals of concavity, just so I know that you can do it. There will be one optimization question, or possibly two, probably very similar to the optimization questions that were in the exercises. Okay. Tomorrow is a review day. I think I can have like a game show so that Maddie can take a shot at number one. Well, everybody can.
Is Eric going to be there? Because I'm not going to come in first place if I'm against him again.
Yeah, I'm hoping that you get your fair shot at Eric. Yeah. Okay, good. I'll just leave the link open. So if you've got any questions, pop back in. This exercise set doesn't take very long to do. I think I assigned like 4 and 5. I think question 1 though is really easy, just for you to get the idea. All right.
Can you do the where you got 1250 with me? Because some reason when I try to plug it back in, I don't get that as an answer.
Okay, I will.